I feel like maybe I should have just done it instead of taking the picture. But anyway. So I did A 2 times in a row. Wow. All right, so our formula, this one looks more like it, right? Our formula to get the angle between two vectors is cosine of theta. Don't forget about that cosine of theta because you have to take the cosine inverse at the end if you actually want to get the degrees. So it's cosine theta equals the dot product on top and the magnitudes multiplied. The dot product, if you remember, is not just multiplying. It is multiplying and then adding the elements. So our horizontal, so that'd be 2 times negative 6 plus 4 times that negative 12. And it'd be all over their magnitude. The cool thing is once you have all these numbers, you could plug all of this into your calculator. You could do cosine inverse of 2 times, and as long as you keep your parentheses, you could plug all this in at once. But simplifying it, you'd come up with a negative 60 over square root of 3,600, which is negative 60 over 60, which is negative 1. If you take the cosine inverse of negative 1, you'll come up with 180 degrees. Or you could remember from the sheet, if you ever have cosine theta equaling negative 1, it automatically makes it parallel. Questions on that? Okay, questions from the homework. Stuff you weren't sure about, even if you got it right, and you're just like, I'm not sure why you did that or anything of that manner. Grace. 9. Is that the 3 times vector 1, 2 plus 4 vector negative 1, negative 2? No. That is not that one? Am I looking at the wrong? What am I looking at? Are you sure it's not that one? Is it the graphing each complex number and finding its absolute value? Okay. Whew. Get that out of here. All right, so let me take a picture of it really quick. So the graph of it would just look like, well, they're both negatives. So it would be in quadrant, I'm sorry, they're not both negative. We actually have 1 square root of 2 to the right and negative 1 square root of 2 down, because this really is just 1 over square root of 2 times I. So let's rewrite that really quick. So this is really can be rewritten as 1 over square root of 2 minus 1 over square root of 2 times I. So that means I can write this as 1 square root of 2 comma a negative 1 over square root of 2. Well, that would be that point right there. Then it says to find the absolute value of it. That is just that length. It is that length from the origin to there. So we really have a triangle. Let's pull that triangle out. We have a triangle that looks like this, where the base of this triangle will be 1 over the square root of 2. And the height is kind of that negative 1 over square root of 2. And so to find this length here, it's just r squared equals a squared plus b squared. In other words, that length equals the square root of our 2 elements squared and added. Is that good? Or did you have a specific question that you just...
No, that's good.
Okay, awesome. Other questions? Fritz? 23. Do you have a specific question, or you just want to see the whole thing? The whole thing. All right. So 23 says 3 plus 4i, right? So we should kind of picture that point 3 comma 4. So starting out there, let's... All right. So what I'm thinking is this is the point 3, 4. So let's plot it. So in order to put that into the trig form, we need to have the length r, and we need to have the directional angle. Well, to get r, we just take the square root of our 2 elements. So that's 3 squared plus 4 squared, which will work our way down to 5. So we know 5 is going to come out front. Now I just need to find my theta. Well, since we are in quadrant 1, let me make that little drawing a little bigger. Since we are in quadrant 1 with our triangle, our theta and our beta are both the exact same thing. This is actually my theta. That is that from that origin up. So whatever I find using this triangle is actually going to be the measure I'm looking for. There's no adding to 180 or subtracting from 180. So it's just going to be the tan inverse of our opposite, which is 4, over adjacent, which is 3, which is always going to be our y over our x. If you're ever concerned about your drawing, it should always be your y over your x when you're using tangent. And that's going to come out to 53.1 degrees, which we plug in. Does that answer all of your burning questions? Good? Awesome. Hey, Liv. Yep. I assume this is just forged, right?
Okay.
Yeah, okay. All right, any other questions from the homework? Yeah, Leo.
33.
33. 33 says we're supposed to write each complex number in the form of a plus bi in rectangular form. I know exactly what happened on that one and why you have a question. You plugged in your calculator and came up with a different answer, right?
Yeah.
Yeah. Look at that 3.7 really quick.
Doesn't have a degree sign, right?
So what mode did your calculator have to be?
Oh, radians.
It has to be in radians. Yep. It's kind of a sneaky place to put it in since it's all degrees and all of a sudden that radian popped up. And 37 is also in radians, but that one you should have been able to use your unit circle on. I was waiting for that one. That is the... I got some emails saying I had it wrong. I'm like, is it a degree symbol? All right, awesome. Let's go on to today's lesson. Today's lesson is multiplying and dividing complex numbers. As odd as it sounds, it is a lot easier to multiply and divide complex number if they're in their trig form. So if you ever need to multiply or divide complex numbers, put it in your trig form, and you're going to have a much easier time coming down to just that a plus bi. Because any complex number can be written as the form a plus bi. You should not have a plus bi all over c plus di. You have to condense it into one a plus bi. Does that make sense? You have to reduce things down. You can't have one giant fraction. And this is the easiest way to do that. And so if you're in trig form, these two things apply. It's a product rule and a quotient rule. So first let's talk about the product rule. Let's say I have to multiply z sub 1 times z sub 2. Well, let's write that down. So we're going to do z sub 1 times z sub 2. Well, that's going to equal both of our lengths multiplied. So that's going to be r sub 1 times r sub 2. That's a bad r. That's a better r. And then you're going to multiply by. You're going to multiply by the cosine of your first angle. So your first angle is right here, plus your second angle. So it's going to be the cosine of your first angle plus your second angle. Then we have plus. We continue with our I. And we're going to take the sine of our first angle plus our second angle. And it is now multiplied. Where you just have one r value, one number out here. And these will be all things you can solve and put in rectangular form. Your division looks almost identical to this one. So if I have to do z sub 1 divided by z sub 2, instead of r1 times r2, you better believe it is r sub 1 divided by r sub 2. Inside changes just a little bit too. So the product was cosine of our first angle plus our second angle. With division, it's going to be your first angle minus your second angle. So we are going to have cosine of our first angle minus our second angle. We're still going to have plus, and that's because we're all supposed to come down to a plus bi. So it's still going to be plus, and it's going to be I times sine of theta 1 minus theta 2, and then you would have been done with your division. You will need to know these formulas. Either you know them and you know how to do the problems, or you don't remember them and they can't do the problems. Because if you actually try to put this over this, it turns into a really hard, complex problem with your angles and stuff. All right, so just know these. These are things you have to memorize for the test. All right, let's put them in practice. All right, I'm given two complex numbers in trig form. Remember, they have to be in trig form to use these properties. So we have z sub 1 equals 6 times cosine plus I times sine, and our angle for both of those is 2.4. For z sub 2, we have 2 times cosine 1.8 plus I times sine of 1.8. Once again, we just have a length of 2 and an angle of 1.8. So if I'm doing z1 times z2, you're just going to take your two lengths and multiply them. So I'm going to do 6 times the other length, which is 2. And then we're going to do cosine of our first angle, which is 2.4, plus, plus the other angle, which is 1.8. And then it's plus I times the sine of the first angle, 2.4, plus the second angle, which is 1.8, which is going to equal 12 times the cosine of 4.2 plus I times the sine of 4.2. Good news is both those angles will stay the same. That is actually it for this problem. Your homework, you'll have to go one step further. And the homework, it asks you to put in rectangular form. I did see some people get out their calculator and are probably doing that. So your homework will say put that into rectangular form. Because realistically, the flow is you have rectangular form. You have like 2 plus 4i times 8 plus 3i. You put it in trig form, you do your multiplication, and then you put it back in rectangular form. That is usually the flow of these problems. All right, but in this case, if that's all I asked for is z sub 1 times z sub 2, that's as far as you have to go. I didn't ask you to put in rectangular form. Division, we're going to do what is said right above there. With division, since it's z sub 1, first we're going to take the first length, which is 6, divide the other length, which was 2, so it's 6 divided by 2. And then it'll be times the cosine of our first angle, which is still 2.4, but now we're going to subtract that second angle, which is 1.8. I feel like I'm going to run out of room. It's still plus because we have a plus bi, so we still have a plus. And it'll be I times sine of 2.4 minus 1.8. And I need that there. Whew. You can barely even tell I tried to squeeze that in. Right? It's always nice when it gets small and it leans down. All right. So simplifying this, we're going to have 6 divided by 2, which is 3. I have cosine of 2.4 minus 1.8, which is going to be 0.6, plus I times sine of 0.6. Once again, your homework will most likely tell you to put that in rectangular form in some of the problems. Just read what they're asking. Don't do more work than you have to. Brody.
So for those who keep it in radians?
I would keep it in radians because those aren't degrees. Yep. So be careful on the homework if you're in radians or degrees. All right. Our next thing is complex conjugates. Complex conjugates are things where you multiply to get rid of your imaginary unit. It's kind of like when you wanted to get rid of a square root. So if you had 2 plus square root of 2, you'd multiply the bottom and top by 2 minus square root of 2. Same idea here. In fact, it looks eerily similar to that because if z equals a plus bi, and I'm asked for its complex conjugate, it's just going to be a minus bi. And we'll see what makes it a complex conjugate by actually doing the multiplication. So we're going to do a plus bi, and we're going to multiply that times a minus bi. Well, I spent a lot of time talking about difference of squares because this is another one of those difference of squares problems. It saves you a lot of time to recognize it's a plus b times a minus b. So you take your first term and you square it, so we'd have a squared. And then we'd subtract our second thing squared. A little bit of legwork, we'd have a squared minus b squared times I squared. Who remembers what I squared equals? Leo? Not regular one. It's negative one. And why it's negative one is because remember your I, what actually is there is square root of negative 1 squared, which equals a negative 1. So this whole thing is going to actually equal a squared plus b squared. Complex conjugate of z equals, well, our complex number in trig form. A little bit different, a little harder to remember, but really you just have to remember the answer to this one. It's going to save you a whole bunch of time. So the complex conjugate is actually r times cosine of negative theta plus I times sine of negative theta. That is our complex conjugate. Here's the cool thing if it's in this form. Let's do the multiplication. We could fit the whole multiplication right underneath. So if I have cosine theta plus I times sine of theta, and I multiply that by r times cosine of negative theta plus I times sine of negative theta, you actually know what that equals. Well, maybe not yet, but you actually know how to get this value without doing the multiplications. And it's because of this. This says it's a squared plus b squared. On a right triangle, a squared plus b squared equals... Not quite. Close. If I'm just talking lengths, remember these are our lengths. Leo? What was that?
C squared.
C squared. What is occupying our c squared part if this is the length of my... So when we're talking about, remember when we plotted a point, this was basically our A, this was our A, this was our B, and this was our R. That was the length. So a squared plus b squared equals r squared. So the complex conjugate multiplied by our trig form is just going to be r squared. This one you can figure out. This isn't one that you really necessarily have to have memorized because whatever you have, it doesn't take much work. It's just squaring numbers. This one you need to have memorized because otherwise you have to go through a whole bunch of work to actually make it happen. So let's prove that it's true on this one. All right, to see how much work it is without actually having this formula memorized. So we need to multiply this by the complex conjugate and see what the result is. Well, the complex conjugate of this will be 2 times cosine of negative pi over 3 plus I times sine of negative pi over 3. So if I had to do this multiplication, we'd have 2 times the regular one, which is cosine of pi over 3, plus I times sine of pi over 3. And then we're going to multiply by its complex conjugate. Its complex conjugate is the one I just wrote above. We'd have 2 times cosine of negative pi over 3 plus I times sine of negative pi over 3. It is a doable problem because if you know this formula, the multiplication formula, you're going to recognize that it's just r times r. So we're just going to have 2 times 2 out front. And then we're going to have cosine of your first angle plus your second angle, which is negative pi over 3. And that's going to be plus I times sine of your first angle, pi over 3, plus your second angle, negative pi over 3. That's going to equal 4 times cosine of 0 plus I times sine of 0, which is 4 times the cosine of 0 degrees is 1, plus I times the sine of 0 degrees is 0. So that just equals 4. On the test, I'm not looking for you to do all that. I'm looking for you to recognize that the product of the trig form equals r squared. So what you should have honestly done, this should be all the work you have to do on this problem, is go, well, that's just r squared, which equals 2 squared, which equals 4. Or you could have just put 4, because, 2 squared is 4. This is what I expect you to do on the test. This is what I expect of you to do on your homework. This is what people are going to do that don't go back and study their notes. Or they'll attempt this, because normally if you didn't look at the notes, you probably didn't even know this formula, and you're actually going to try to actually do this full multiplication. This is that problem that sucks all the time out of the test. This is the problem where you come talk to me and you say, this test was too long and I ran out of time. Studying your notes makes it this easy versus having to do all of this work. When I put this question on a test, I expect it to take a minute max, and that's for time for you to think about it, think back at your notes, and remember that it's just r squared. This is one strictly, did you look at your notes and do you know what I mean by multiply by complex conjugate, and to remember that it's just r squared. Yes?
You don't really even need to write anything on the left side of the equation now?
I want none of this on the test.
All right.
This is max work. What I mean by max work is you probably could have just put 4 because 2 squared equals 4. But it's always a good idea to put 2 squared just in case you made a mistake. Like 2 squared equals 6 for some reason. I don't know.
Yeah.
It wouldn't be out of the realm of possibilities on a test, doing something like that. This is all I want. This is all I want in your homework. If you look at my answer guide, this is all I put. I actually just put the answer down. All right? Don't waste time on the test. All right, I think I beat that dead horse long enough. Study your notes. Study your notes. Study your notes. All right, I kicked it a few more times. All right, example 3 is kind of the full problem. It gave us 2 complex numbers in rectangular form. It says put them in trig form and then divide and multiply them. So in order to have them in trig form, we must first put them in trig form. Crazy, huh? Trig form is r times the quantity cosine theta plus I times the sine of theta. You need 2 bits of information. You need r. R is your length or magnitude or absolute value, however you're calling it. It's all the same thing. It is your length of that hypotenuse. Theta is just your directional angle. So let's go ahead and start by doing our trig form. So let's do trig form of z sub 1 first. So that's -2 plus, I'm going to change the format just a little bit for us. 2 square root of 3 times I. Sometimes it's nice to write that way so that you realize that it really is just the point negative 2 comma 2 square root of 3 on the imaginary plane. All right, let's go ahead and plot that. So it's negative 2, 2 square root of 3. So that's going to be in quadrant 3. So let's focus on quadrant 3. It'd be somewhere, I don't even care where I put it, just somewhere up here. So if I did a little triangle for that, the base of that would be my negative 2. The height would be that 2 square root of 3. That r is the length of that line. R squared equals a squared plus b squared. So in short, r just equals the square root of both your terms squared. So that'd be negative 2 squared plus 2 square root of 3 squared. All good? All right, that's just going to equal 4 if you do it correctly. Because 2 squared is 4. And 2 squared of 3 squared is actually 4 times 3, which is 12. 12 plus 4 is 16. So square root of 16 is 4. All right, so my r value is 4. Now I just need to find my theta. Don't forget that your theta is that whole measure. It's from that initial side to our terminal side. Because I don't know that actual value, all we can find is beta. We're going to first find beta, which is going to help us find theta, the beta-theta connection, as the kids call it, right?
Definitely.
Okay. I'm in the know. All right, so we're going to do tangent of beta equals opposite over adjacent, so that's 2 square root of 3 over negative 2. So actually I'm taking the tan inverse to get this, so our beta equals the tan inverse of, well, 2 divided by 2 is 1, so this is just the square root, negative square root of 3. Oh, man. Negative square root of 3 is on the unit circle. Crazy. So this could be on one of the ones that say you can't use your calculator. Well, tangent's only in quadrant 1 and 4, tan inverse r. Negative 1. So it must be negative, and it's negative 60 degrees. All right, but that means I need to find theta, especially because it's negative. Is it going to be 360 minus 60, or is it going to be 180 minus 60 on this case? You know?
180.
It's going to be 180. Yep. Which equals 120 degrees. All right, so my trig form is then going to be my r value, which is 4, times the quantity cosine of 120 degrees, plus I times sine of 120 degrees. Oh, now we got to do that again. You should be able to do this quicker because you're not explaining it to yourself as you're doing it, like writing it out. Hopefully by now you're moving a little faster than I am. So our next one is square root of 3 plus I. Don't forget there's actually a 1 in front of that I. So this is going to be the point square root of 3, comma 1. If you plot this bad boy on here, they're both positive, so it's going to be in quadrant 1. It's going to be right up here. Connect that point, make my triangle. The base is that square root of 3. The height is 1. The r is the length. It is our magnitude. It is our absolute value. Tomorrow we'll learn another word for it, but it is always the same. It's our length. To get our length, it's just r equals the square root of a squared plus b squared, or x squared plus y squared, or v sub x, whatever you have. Your first element times plus your second element squared. So we're going to have r equals the square root of square root of 3 squared plus 1 squared. Well, square root of 3 squared is just 3. plus 1 is 4. Square root of 4, last time I checked, is 2. In this case, we are in quadrant 1, so our theta and beta are in the exact same spot. It's just this angle here. So I'm going to go ahead and call it theta right off the bat. So we can say theta equals the tan inverse of opposite, which is 1 over square root of 3. For those of you following along, it is always y over x. It is always that y value over x if you're doing tangent in this method. Okay, well, tangent of negative 1 over square root of 3. If I multiply that by square root of 3 over square root of 3, that is square root of 3 over 3. That is on our unit circle as well. Wow, we could do this entire problem without a unit circle, or without our calculator. Equals 30 degrees. And we're done. We have our R value, 2 times cosine of 30 degrees, plus I times sine of 30 degrees. Brody, kind of a question.
It says it's 52 degrees.
Do you take the... Are you sure you're in degree mode?
Oh, I'm not.
Because 1 over square root of 3 is on our unit circle.
Yeah, that's right.
All right, now what we have to do is multiply and divide them. That's the easy part. Because multiplying and dividing, we have a formula for it. So let's keep those values. So we're doing z1 times z2. I don't have those values because I can't see them up here. But we're going to end up doing 4 times 2. Because our length is 4. Our second length is 2. Times the cosine of our two angles added. So that would be 120 degrees plus 30 degrees. And it'd be plus I times sine of 120 plus 30. Which is going to equal 8 times the cosine of 150 degrees plus I times the sine of 150 degrees. Here's where you'd look at the directions. Do the directions say anything about rewriting it in rectangular form? Nope, so you don't have to, you're done. However, would it be fair game to say write it in rectangular form now? Yes, because you know the cosine of 150, or you should. The cosine of 150 is negative square root of 3 over 2. Sine of 150 is 1/2. You distribute that 8, and you'd be in rectangular form. So it is completely possible for me to say, start in rectangular, go to trig, complete the multiplication, and put it back in rectangular form. So just know, depending on the question, you might have to go one step further. All right, division. If you know multiplication, you probably know the division one. First, instead of multiplying 4 times 2, we're going to do 4 divided by 2. Instead of cosine of 120 plus 30, we're going to do 120 minus 30 degrees. And then we're going to do plus I times sine of 120 degrees minus 30 degrees. All right, which is going to equal 2 times the cosine of 90 degrees plus I times the sine of 90 degrees. So this entire problem is one that you're not required to have a calculator for. Everything was on our unit circle, and you could go from rectangular to trig back to rectangular without a calculator. All right, real quick on your homework. I want to make a small change. Don't get too excited. I'm removing all the on number 63 and 65, I'm going to make them easier on you. For 63 and 65, use the rule or the guide from 67 and 69, which says find the product of the given complex number and its complex conjugate in trigonometric form. So that means all 4 of those problems should take almost no work. What I mean by that is there's one way to do it, and then there's another way to do all 4 of them. One is probably a good way. The other way is probably not a good way. All right, everybody. Have a wonderful... Ooh, we still have 2 minutes. Let's all sit here and look awkwardly at each other. No. All right, everyone have a good day while I check this homework.